Thank you, first of all, for organizing this event again. So Benny, Ruben, Gabe, thank you for putting this together. And of course, to all everyone who's tuning in, thank you for joining us today, or maybe you're watching this as a recording later on. But let me quickly introduce myself. My name is Jits Langedijk. I'm a solutions architect at NVIDIA, focusing on professional visualization, active community member as of many of us today. And of course, a proud member of TeamRGE. The title of this session was an NVIDIA GPU update on the end-user computing space. And of course, TeamRGE stands for the Remote Graphics Expert. So we're talking about the GPUs with which we provide for the data center to accelerate both compute as well as graphics virtualization. Sorry, not virtualization, but workloads, both in virtualization as well as in bare metal or pass-through configurations. So with a GPU accelerated data center, of course, we are able to accelerate each and every workload for different use cases. And of course, when we talk about remoting graphics, it's all about like VDI and maybe server-based computing or WVD when we talk about cloud instances, for example. And this is everything to do, of course, with providing access to your applications, your data on any device over any connection. It eases up the collaboration, especially today in this global pandemic, where we use a centralized and maybe a virtualized environment to collaborate within the organization, but also outside of the organization, or collaborate like such events as this. And of course, centralizing all your data within the data center, providing one single source of truth for your the employees within the organization is also helping organizations to increase security and protect their intellectual property. And in the end, when you consolidate all your different workstations, physical workstation, mobile workstations into one centralized environment, this also helps you to reduce costs. And luckily, as many already today mentioned during their sessions, we believe, of course, and not we only as NVIDIA, but both from a personal side as well, I believe that whenever we are used to a certain user experience with our physical devices, which all have GPUs, the same user experience is also something that we kind of demand from our virtual machines sitting in the data center or maybe in a public cloud offering as well. So let me quickly explain how this virtual GPU works in a data center solution. So to the left, we have our typical server. We have a piece of hardware. We have a hypervisor, and on top of that, we are able to run virtual instances, virtual machines, and applications, and provide access, secure access for each and every user within the organization. So now with the NVIDIA vGPU technology, we have the same server, but now we add a physical GPU in there, and we install a virtualization software piece into the hypervisor. And now all of a sudden we have the ability to carve up a physical GPU and assign virtual GPU profiles to different virtual machines. So depending on the amount of frame buffer, we can either assign all the frame buffer to one virtual machine or carve it up into, I don't know, 16, 24, 48, 32 different virtual machines and allow them all to have access to this physical GPU. So this, from a pricing point of view, this really helps, of course, because now we have this one-to-many scenario instead of a one-to-one relation. Well, we can spread out the cost, of course, when it comes to GPU accelerated virtual instances. Now, last month on May 14, we had our GTC online keynote announcements, and our CEO Jensen also mentioned our latest and greatest, the A100 NVIDIA GPU. So the A100 is based on our latest Ampere technology or GPU architecture. And there was also something mentioned like the multi-instance GPU, MIG. And ever since, I got lots of questions by our partners and end customers. How does this relate to vGPU? So with the MIG feature, we have the ability to now carve up a physical GPU on a lower level, so to speak, and have different GPU instances. So in this particular example, we have 3 instances. And these are all isolated from each other, and they have their own cores, their own layer 2 GPU memory, and there's a, well, complete isolation and quality of service between all those instances. So this really, again, allows a more flexible workflow in your organization with one or multiple GPUs. Bear in mind, this is compute only at this time. So back to the original question, how does this relate to NVIDIA Virtual GPU and flexibility with MIG mode? To the left, we see the MIG mode disabled. So this is how we used to know vGPU. And this is more or less time sliced. All the cores are shared between all the different virtual machines. And of course, we have different abilities to time slice this. So schedulers to make sure that there's no suffering from a noisy neighbor effect, for example. But with MIG mode enabled, as you can see, underneath the hypervisor, we carve up these physical GPU, and now all of a sudden you're more or less within the hypervisor. You have 3 GPUs which you can assign in a pass-through configuration in a one-to-one relationship, or well, not only pass-through but also with vGPU, of course, but only the entire GPU or temporal partitioning is assigned to one of the virtual machines. So just to give some clarification on vGPU in combination with MIG mode, bear in mind it's compute only today. So let's get back to the original topic, GPUs for end-user computing. As many of you know, we have different GPU architectures. We started especially with vGPU with the Kepler architecture. There were some architecture before even Kepler, but we started back then with the K1 and the K2 purpose-built GPUs for vGPU. And now we're at Ampere, and then of course we divide our GPUs more or less into the Quadro brand and the Tesla brand. So the Quadro brand are our GPUs that you would typically find underneath your desk in a workstation or maybe in a mobile workstation. So these are excellent solutions for a physical workplace without the need to provide access on well, any device over any connection. So now when we move towards the data center, of course, where we have the Tesla brand, we can use both the Tesla GPUs for different use cases, of course. So we have the high performance compute, deep learning, machine learning, where we focus more on the compute or maybe some basic graphics. And then, of course, we have the desktop virtualization piece. And of course, we have different GPUs that we can use in this scenario. And when we talk about desktop virtualization, there is obviously a hypervisor involved. We have NVIDIA vGPU technology, and we still have the pass-through technology as well. And in a high-performance compute scenario, we can either do bare metal or we can do pass-through. Keep in mind that when we talk about vGPU and pass-through for desktop virtualization, a software license, so the NVIDIA vGPU software license is required. And we have 4 types of licenses depending on the use case. So a lot of information into one slide, and yes, we can do even better, but I think this is the most well, up-to-date lineup when it comes to GPUs available now and supported now with vGPU 10.2 in our vGPU offering. So as you can see, when you're really seeking a high-performance optimized VDI instance, whether that's compute or graphics, the V100 or more towards graphics, the RTX boards are your GPU to choose from. Maybe when you have some entry-level 2D, 3D CAD design, not really this high-end use cases, a T4 would be a good candidate as well. And then moving more towards the more generic Windows 10 office productivity use cases where user density is more important. It's either one or multiple T4s or the M10. So as we've seen on the previous slide, the M10 is a slightly older GPU architecture with no support for H.265 or VP9, for example. But then again, from a pricing perspective, still a very interesting board for a density optimized configuration. And for those customers who are running with Blade servers, a P6 is available. So this is all in your own private data center. And of course, as we have seen in different sessions already, we also have lots of GPUs available in different public cloud offerings. So Amazon, AWS, Microsoft Azure, Alibaba Cloud, or GCP, Google Cloud Platform. They all have different instances available with GPU acceleration. And as Ruben also mentioned, Alibaba is the only one who's providing vGPU instances, while all others today are offering a more or less a one-to-one relationship, a pass-through or DDA configuration. And we also provide either the ability to bring your own license or to consume an instance with an NVIDIA license already built in. So we have plenty of things to choose from for each and every one of you. So on-premises or cloud, and as I said, we have different use cases, graphics or compute. And I think for compute, it's very important to highlight this virtual compute server that we introduced with version 9 of vGPU. So with virtual compute server next to the multi VM per GPU, which is basically what we started off with vGPU, we now have the ability to aggregate multiple virtual GPUs into one virtual machine. So it's the other way around, but especially for compute use cases, very useful. We offer support for peer-to-peer over NVLink technology, so you can have also physically connect two GPUs to each other and assign it to one virtual machine. We have ECC and page retirement, support for the NVIDIA GPU Cloud, our repository where you can download pre-trained models, all kinds of frameworks. So really for the data scientists to get the data scientists up and running right from the start, instead of gathering all their information, all their software from different places and building their own environment. Now they can initiate a Docker pull command and they get this NV Docker container and get started right away. And as I mentioned, this time slicing with the virtual compute server, we have this enhanced flexible scheduling where you can manually configure your time slices or scheduling of the physical GPU. So the ones to the right are all new features with virtual compute server, and just to get us more on feature parity when it comes to bare metal, because the compute workloads are used to be more on a bare metal deployment, and now we're offering this as well on a virtualized environment, and customers can benefit from all the flexibility that a virtualization solution has to bring. Like management, monitoring, and migration, for example, and really make use of your investment. So that was vGPU 9. And of course, with 10, we're currently at 10.2. We have some new features implemented, like the flexible display enhancement. So you have now a more flexible way to configure a vGPU profile for different physical monitor setup. So whether you're using two full HD or an ultra wide curved high resolution monitor, or a 4K or an 8K or a 5K, it's much more easier for an IT admin to create a virtual machine pool with a vGPU profile assigned to it. We have offered the support for the RTX 8000 and 6000, both for the active cards as well as for the passively cooled cards. So when we introduced the support for the RTX 8 and 6000, this was only for QVDWS, so Quadro licenses, and now we're also supporting those cards for virtual apps, so the RDSA, Citrix XenApp, Horizon Apps use cases, as well as for the virtual PC use cases. Support for the V100, so if you have V100s and you need those in a virtualized environment with vGPU, you get full support, and also for the V100S. And a very important new feature is the cross-branch compatibility. So for those who are familiar with vGPU, we have different major branches or releases, so 10, 9, 8, etc. And there's always, of course, a piece that you install into a piece of software, into the hypervisor layer as well into the guest OS, and there was always this dependency. So whenever you wanted to upgrade from version 8 to version 9, both the host as well as the guest needs to be on the same major release. And now with 10, we introduced this cross-branch compatibility. So once version 11 will get released, you have, especially for service providers, this is a great feature. They have the ability to upgrade all their hosts, or test with one, of course, first, but to upgrade all their hosts and then gradually also update their guest virtual machines. And of course, we also provided support for the latest Citrix, Windows, Red Hat, VMware versions and releases of their brokering and virtualization solutions. As I mentioned, we have 4 licenses available today. So starting from the left, more for the knowledge worker use case on a RDSH environment, or Citrix XenApp, Horizon apps. So when you were using a server operating system, we have the virtual apps. Then next to that, we have our virtual PC. This is the Windows 10 Office Productivity user. And then, of course, when you really need all the features that are available within vGPU, you need like the ECC page retirement, the Quadro support with your certification for all these heavy graphic, these applications that really rely on graphics. We work very closely with those ISVs to make sure that these applications really work best on NVIDIA GPUs. So that's the Quadro certification. That's really important there. And then, of course, this new use case where the data scientist for AI, deep learning, machine learning, or a high-performance compute workload, we can serve them with the Virtual Compute Server software version. And looking at the time, I think I have 2 minutes left. And that's excellent, to be honest, because when I look at the entire landscape, and yes, I'm aware this slide has a lot of information, but let me explain. I think when we look at vGPU, in essence, virtualization and GPU virtualization, this was always a play on the professional visualization, the graphics. So especially this high-end 3D CAD designer, or I don't know, maybe someone from using the Adobe suite, for example, to make sure that those people have the ability to do their work in a proper way. And also, of course, the Office Windows 10 productivity users. This is common ground to most of us, I think, in this space when we talk about end-user computer. And with the Virtual Compute Server, this opens up a complete new use case. So whether this is HPC, deep learning, machine learning, more the AI type workloads, these employees within an organization, they were used to work on their own white label machines, not benefiting from the virtualization technology that is available within the organization. So I would really encourage each and every one of you to seek within your organization and seek how you can help your fellow coworker to work in a more productive manner and also benefit from all those key drivers that I mentioned at the beginning, like collaboration, work from anywhere, one single source of truth. I think there's a huge opportunity for each and every one of us. And if you need some help with that, please reach out. I'm always happy to help out. And with that, Gabe, I think, maybe right on time.
Excellent job.